Say this is bus 1 and this is bus 2. Let's understand the connections. After the voltage has been raised by the transformer of generated power, the high voltage line conductors is passed through the current transformer so that current in the line could be measured. After that, these conductors reach to the gantry. Voltage transformers are installed here to measure how much voltage is on the line conductor due to the transformer. However, these look like current transformers, but these are connected in parallel to the line conductor. This means that one of their terminal is connected to the line terminal while the other terminal is connected to the earth. In the secondary circuit of each transformer, a voltmeter is connected so that we get regular information of voltage of each phase. From this, after the gantry, the supply will go to both the buses. For this, the conductors will go down, then go through the isolator. After this, surge arrestor is installed, then the current transformer will be installed to measure how much current is going on this bus. Then circuit breaker, then isolator, and then finally these conductors are connected to bus 1. Similarly, the connection is also go to the bus 2 and will follow the exactly same sequence. First isolator, then surge arrestor, current transformer, circuit breaker, isolator, and finally it will be connected to bus number 2. As incoming line is connected to both the buses, and if both these breakers are on, so the buses remain energized from the incoming power. In exactly the same manner, the connection of the second transformer will also go to both buses. They will go to the first bus from here and the second bus from here. Generally, all the circuit breakers will remain on, so the buses remain energized. Let's consider here the generation of power is happening at 11 kV and we are stepping it up to 220 kV for further transmission. So, the bus is having 220 kV. Now, a connection has been taken out for further transmission of electrical power. So, from this bus, we take the connection through this path, and from this bus, our supply will go through this path. If this circuit breaker is switched off, then the power will continue from this path, and if this circuit breaker is switched off, the power will choose this path. If both the circuit breakers are on, then power will continue from both the path into the transmission line for next destination. This is the first circuit of transmission line and this is the second, for which we have same arrangement. Here we have 3 line conductor for second circuit and similarly 3 line conductor for first circuit. Now, what are the advantages of having 2 buses? Let's understand this. Suppose due to some fault, this circuit breaker becomes switched off. The power will not enter into bus 2 and will completely start entering into bus 1, which was partially entering into both the buses. And it will continue further into the transmission line from bus 1. Suppose this breaker gets off, then the power will continue from bus 2, so the continuity will remain. It will never happen that our supply will completely stop. Same thing is applicable in the case of another incoming line, which is coming from the another transformer. Like if this breaker gets off, the power supply will continue from here, and if this one is off, then it will goes from here. There is a bus coupler between these 2 buses which helps to couple both the buses electrically. It consists of a circuit breaker and isolator on either side, which are used to isolate the circuit breaker during the maintenance. Current transformers are installed in bus coupler to measure how much current is flowing from bus 1 to bus 2 and from bus 2 to bus 1. These are post insulators which are used to give support to the conductor when distance is large enough so that conductor could not come into the contact with the ground. Bus coupler is very useful during the time of maintenance. Like, to do the maintenance of this circuit breaker, the bus coupler must be switched on, so that the coming power from this line will transfer to the bus 2 through this path and finally reach into the transmission line. So we will not felt any problem in switching off this breaker. After getting done with maintenance of the circuit breaker, it could be put again in duty so that the power again reach in both the buses from this path. And the bus coupler could be switched off. During the time of maintenance, the circuit breaker must be isolated from the system properly, and for that we use isolators. Like, when the isolators are operated, their rods rotate like this, they become off. And now we can do work on the circuit breaker safely, though there is a charge on the bus. These terminals are connected to earth so that even after closing, the remaining electric charge in the breaker goes completely into the earth. Otherwise, the maintenance personnel could get a severe electric shock if they touch the circuit breaker. This complete assembly is called as bay, and inside the bay, it consists a number of equipment, and on each equipment, we could do work safely by isolating them with the help of isolators. Similarly, if we want to do the maintenance of this circuit breaker, then we have to ensure that the bus coupler is switched on. As power is coming from these lines and also reaching in this bus, if suppose these breakers are also at off position due to regular maintenance, however, both the buses is getting charged due to bus coupler, and we could switch off this breaker and could isolate it from the rest of the system by operating the isolators without interrupting the continuity of the power flow. These are the surge arresters which are used to earth the voltage surge produced in the system during the switching operation, or it could be a rise in the system due to lightning strikes on the transmission line during bad weather. To understand about it working in detail, you could watch our another video. The link is given in the description also. The current and voltage transformer installed at different places in the system not only measure the value of current or voltage in respective line, but also give input to the relays, which detect any abnormal change in their value and operate circuit breaker to take preventive action and therefore protect the complete system. So this is about double bus arrangement which our power plant switchyard generally consists. Friends, there are around 6 type of bus arrangement which are used in switchyards. We will try to cover these arrangement in different video. So I hope you get the concept of double bus arrangement which are used in switchyards, and also hope you like the video. If your answer is yes, please hit the like button, share with your friends, and new viewers, please subscribe our channel so that you will get notification of our upcoming video. And at last, friends, thank you so much for watching the video till the end.